Hi class, this is going to be your introduction to metamorphic rocks for the lab. I'm going to go through all the different metamorphic rocks that you might see in the lab. We're going to talk about them, what they look like, what kind of attributes you want to look for to try to identify them. We're even going to compare them to the metamorphic rock identification key and what kind of things you see on there. And by the end of this video, you should be able to identify each of them in the lab. The first thing I'm going to start with is a rock that is actually not metamorphic. This up top is a shale. This is a sedimentary rock, so basically like a mudstone. These haven't been showing up well on camera, so I'm actually going to use a flashlight to kind of show you the sides. And you can see the top and bottom look a little bit different from the sides, so we're going to concentrate on the sides here. And hopefully you can see the layering that's going on. First off, the shape of it is very flat on the top and bottom. That's one of the layers of an overall shale formation that this rock would have come out of. Secondly, on the inside, you can see some sort of layering going on. It's going to be hard for me to kind of point at it, but that layer right there on the inside is one of them. And if this were a little bit better, a little bit more close up, you could see several different layers. I think maybe if I hold my light, you can see them just right here. But there are several different little layers inside this one overall piece of shale. And so this is a mudstone. The particles inside are very, very small, and it's mostly just made up of compressed mud pieces, mud-sized particles. So this is going to be the beginning rock that a lot of these metamorphic rocks actually come from. So to show you the next step up, I'm going to grab this slate. Slate is essentially a metamorphosed piece of shale. So notice that this piece of slate is quite a bit darker. Also, I think you can see that it's a little bit shiny. So if I hold it up here, you can kind of see the shine on it, where the shale really is not shiny at all. It's just kind of a muddy, kind of dull rock. The slate is shiny. Also, I don't know if this is going to get picked up well at all. They have a different sound. The slate sounds very much more solid, where the shale, you tap it on the table, you get that sound. The slate, it's not really picking it up. The sound isn't too different between these two. But if this piece of slate were a little bit more flat instead of a round piece, kind of like I have, you would be able to hear a little bit of a ringing sound because it's much more compressed and the molecules are much closer together, the particles are much closer together, and it's just a more solid rock instead of just kind of like a muddy piece of rock. So this is shale, no, this is slate. This is your first metamorphic rock, and I can zoom in here and you can really see some of the layers that have come out. You can see them pretty well on this side. I'm trying to get the light up here. So you can see the layers there on the side here. If we go to this side, you can see more of the layers. And so this is going to have layers very similar to the shale, but it's been compressed, it's been heated, and it's now entered into the realm of metamorphic rocks. This is the lowest grade metamorphic rock. So if we look at the metamorphic rock identification sheet, slate is right up top. You can see that the minerals have all aligned in a flat plane, which is what gives it those layers that we just saw. Its parent rock is from a shale, which is why I showed you the shale. And you can see that shale can be the parent rock of many of these top four metamorphic rocks. And one thing this doesn't show, this is kind of a gradation. Slate is going to be your least metamorphosed. Then if you metamorphose it a little bit more, it goes to phyllite, a little bit more goes to schist, and then gneiss is going to be the highly metamorphosed rock, or the one that's undergone the most heat and pressure. So slate is the least amount of heat and pressure, gneiss is the most amount of heat and pressure as far as the foliated rocks go. So this is our first one. This is going to be slate, just this black, somewhat shiny metamorphic rock. A little bit shiny, but not a lot here. Next, we're going to go to phyllite, which is next on the list, just below slate. It still has the alignment of the grains, but they're not quite flat. They're going to be somewhat compressed, and they're going to have this wavy kind of feature to them. Also, the grains are a little bit larger. Instead of very fine, they're going to be fine grains. And so what you'll see in this rock, instead of just being black and kind of seeing very, very small grains, you're going to really be able to see some individual grains in phyllite. Some of them have kind of come out from, if there's any metallics in this, you can kind of see the metallic sheen. It also could be some biotite and muscovite, which are common in clays or muds that you see that are building up this type of rock. So shale, slate, siltstone, these are going to have biotite and muscovite, your clay minerals in there, and you can see some of those coming out. So it does have this kind of glittery sheen to it. As I move it around, you can see the glitter. Let's see. You're not going to see a lot of layering here. On this side, you can see it a little bit, especially kind of from this direction. The layers, or the shiny minerals all kind of go in the same direction. And so that is that alignment of mineral grains. You can kind of see them all sparkle right here if you're looking at them from above. So if you look at them from the side, you're probably not going to get nice detail on these, but they're all aligned kind of flat from left to right as you view this. So this is phyllite. Notice that it's not quite as dark as the slate. You still don't have much planes showing in this one, the foliation, but you do have that nice sparkly part, which is pretty common in phyllites. So moving on to the next one on the list, we go from slate to phyllite to schist. Schist is going to have some of the sparkles. The grains are going to be a little bit bigger. So you can see it still has the sparkles. The grains are going to be a little bit bigger. One thing I think you maybe start to notice in schist, where in the slate it's nice and black, the phyllite has gone to like a grayish color, but you don't really see much separation. It's just kind of like an overall gray with some sparkly in there. When you get to schist, especially this sample, you really start to see some of the minerals start to separate. So you can clearly see areas of lighter color, whitish minerals, and clearly see areas of darker colored black minerals. Still a lot of shine, and I'd even argue that the pieces that were shining in the phyllite have grown even larger. And so it still has the shine, but the pieces that are shining seem to be quite a bit bigger instead of little tiny ones. And so this is pronounced schist, and if the conditions are right and your schist is metamorphosed enough, you can start to have little garnets come out. And so I think you can see those here. These little red crystals that are sticking out of the side of this one, there's not many there, there's more over here. These little red crystals are garnets that have been squeezed out. And so this is a brand new mineral that was not here when this rock was still a shale. But through enough heat and pressure, the minerals, the elements inside of the shale have realigned themselves. They formed new minerals. And what you get squeezed out of here is some little garnet pieces. These are actually pretty large for a shale, but some nice garnet pieces. And so if your shale happens to have garnet in it, it will just, or your schist happens to have garnet in it, it will just be called a garnet schist. So that's what this is. So this is kind of the same rock, just a regular schist, and then with the garnets in it, it's going to be called a garnet schist. So now, moving on to the last of the foliated metamorphic rocks. All of these are called foliated because if you look at the alignments of the mineral grain, they all have some sort of flat planes or alignments where they're all kind of aligned together. So the slate is very flat. The phyllite, they're all aligned together, but they're a little wavy. The schist is still very flat. The alignment isn't as great, but it is there. And then when you get to gneiss, they're aligned, but they're really separated from black to white. And so in gneiss, you don't really see the rock breaking into different planes. What you do see is these nice white and black bands, almost like tiger stripes. So anytime you see these white and black bands, it's a safe bet to say that this is going to be a sample of gneiss. Now that is pronounced without the G. It's spelled Gneiss. The G is silent, and so it's just like nice, like yeah, like nice. Okay, nice. That was bad, but I'm not going to edit it out because there it is. So this is a sample of gneiss, and you can see on the chart here, if you look at the sample of gneiss, maybe that's not the best picture, but it has the nice white and black tiger striping going on as the minerals separate from black to white and kind of pull themselves out into different stripes. So these are your 4 foliated rocks, and just as an example, you go from non-metamorphosed here with the slate, then your first metamorphic rock, non-metamorphosed with the shale. And your first metamorphic rock is going to be slate, a nice deep black one that's a little bit shiny. The next one's going to be phyllite, that's even more shiny and more of a gray color. Then you can get into your schist, which maybe has the black and white separations, but they're not into stripes. They're just starting to separate. Still going to be quite shiny. Your pieces are getting a little bit bigger here. And if there's the right kind of minerals, you'll get some garnets kind of popping out, which will be a garnet schist. And at the very end, you will get your gneiss rock, which this one does have some sparkling going on. I don't know if you're seeing it in the video, but in general, these rocks aren't quite as sparkly or shiny as the schist and the phyllite. Those are the two that really have a lot of the shiny parts, where the gneiss is more of just like a black and white rock kind of. Although this sample does have quite a bit of sparkle going on. So these are your foliated metamorphic rocks. Towards the bottom half of the list, we have our non-foliated. And I don't have a lot of samples of these. There's not a lot that we're going to do with these. So I'm really just going to show you the 2 main non-foliated rocks, which is marble and quartzite. You can see here in these pictures there is no alignment of the grains. It's just random distribution of the grains. They're both medium to coarse size grains. The only real difference here is what was the parent rock. What rock was this before it got metamorphosed? With marble, it's a limestone. And with quartz, it's going to be a sandstone. And I don't have really good samples, but I would point out to you that while you'll probably see these samples in the lab, we generally think of marble as being white, and that is pretty common. It can be lots of other colors. This is a sample of pink marble. You can even see like a dark gray kind of stripe going through it. And so marble can be a lot of different colors. It's not super common, but white is not the only color to happen in marble. And with quartzite, it can really be a lot of different colors. This comes from a sandstone as opposed to a limestone. Where are we at here? Your quartz sandstone, so it's mostly quartz in here. And as you know from minerals, quartz can be almost any color. And so we have a red quartz sandstone here. I have one that's a little bit more white. It's kind of like a dark brown on the sides. But on the front here, you can see it's kind of like a whitish color, not too far away from the marble. But I have seen completely white quartzite, just like this piece of marble. I've seen pink quartzite, just like this, and they're kind of hard to tell apart. And so the main way you're going to tell your quartzite and your marble apart, your quartzite's going to be a little bit harder, not a lot, because they have been metamorphosed. And so this is not necessarily a soft rock. It's just softer than your harder quartzite because of the minerals that go into it. But the main way that you tell these 2 metamorphic rocks apart is whether they fizz or not. And so the one that has limestone as a parent rock, which is your marble, it's going to have calcite in it. And that calcite is going to allow it to fizz. So for example, if I take this white piece of marble, drip some acid on it, it's not great, but you can see a little bit of bubbling happening there. think you can kind of see it moving around in the reflection of the lights. So you get a little bit of fizzing and bubbling going on with this piece of marble. Let's see if the pink piece does it as well. Yep, I drip it on there. This one's working a lot better. You can see the fizzing and bubbling going on with the marble. Where if I take the quartzite, there should be no fizzing going on. Yeah, I drip it on here. And first off, it almost kind of just absorbs it. But there's no fizzing happening, no bubbling, no reaction. Same thing with this piece of quartzite. Put it on the side here. Put a big old drop, and you really don't see any fizzing or bubbling at all. And so the quartzite is not going to react with the hydrochloric acid. The marble is, because it has a limestone parent rock. It's got calcite in it, and that is going to cause that reaction. So these are your metamorphic rocks here. We have our foliated ones on the left, going from shale, which is a sedimentary rock, not a metamorphic rock. And then we start with slate, which is slightly metamorphosed. We go to phyllite, schist, and gneiss. And then on our non-foliated side, we have marble, which fizzes with acid, and quartzite, which does not fizz with acid. No hydrochloric acid bubbles. So I hope that helps you out with the lab. I will also post this metamorphic rock identification key, and there will also be a lab video posted that shows you the different samples in the lab setting so you can try to identify them. If you have any questions, please, as always, email me, and I will get back to you. Thank you, and good luck on the lab.